Well, hello, everyone. Thank you for attending today's webinar, Next Generation for 911, Next Generation for Core Services and GIS Implementation, Lessons from the Field. My name is Amy, and I am the Membership Associate at the National States Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to learn more on information on how to get involved, please visit us at www.nsgic.org. I will pop that into the address in the chat box shortly. Just some reminders for our call today. All attendees have been muted on entrance. There will be time at the end of the presentation for Q&A, and during our presentation, our chat will be monitored for questions and comments. If you'd like to add any questions or comments, please place them into the chat box, and they will be read aloud at the end of the presentation. Additionally, a recorded version of this webinar will be made available afterwards, so be on the lookout for that. And with that, I'd like to introduce today's presenters, Richard Kelly and Jim Kringle of 911 Data Master. I will now turn it over to the presenters. Thank you for joining us. Richard?
Thank you, Amy. I appreciate it. Hope everybody's doing okay today. How's the volume, Amy? Can you hear me okay?
Yes.
Jim, how are you? Can you hear your volume? Mr. Kringle's with me today. So let's get started. Richard Kelly, Vice President, Geospatial Solutions and 911 Data Master. I've got about 25 years in the business of building and managing GIS data and creating GIS applications for that data for public safety, primarily 911, but I also come from a background of government at regional level, county, and working with state and federal agencies. So we've been around the block. Jim, you want to introduce yourself a little bit?
Sure. My name's Jim Kringle. And as Richard said, we both operate within 911 Data Master. Similar experience in working with local and regional governments in 911 side. I'm one of those rare, as is Richard, one of those rare folks that found their way into 911 after becoming spatially enabled people from the GIS side. So we walked in, and as many of the people coming into the industry now are, we got to walk in saying, I'm very confident about what GIS is, but what all this new MSAG and ALI and 911 trunks and all this new stuff, that's all been the learning experience. And as we've seen that once you get into 911, it's a lifelong pursuit.
Yeah, so, and we've got some great content for you today. You don't have to write it all down. You're welcome to the deck when we're done. As Amy mentioned, we'll have a recording afterwards as well. It's a privilege to be here today to go through this with you. We're going to try to strike a balance during the presentation of discussing what needs to happen and what we're seeing happening in the field. I think this is important for NSGIC, the membership, the states, and the federal agencies that are present today to see this. Also, we're glad to see some of our colleagues from other companies as well who are dealing with the same things. We'll go through all of this today. We're going to try to be non-specific about sites, but we will cite different examples that do come directly from sites. We work with sites that are small and large, from the largest city in the U.S. to the smallest town and community, and it's all over the place, some of the things we're going to go through. A little background about us. Data Master has about 25 plus years of database experience. We handle about 100 million subscribers of 911 records, 24/7, 365. And we're very proud of that. We're the second largest provider of that kind of record support. We are the largest provider of self-maintained 911 databases in the world. We also support civilian and military installations. So whether it's NASA or the NSA, the Pentagon or Houston or wherever, we work with a lot of sites. But besides all that, one of the things I'm very proud about with Data Master is the ongoing education aspect. I would say first and foremost for us, and many of our colleagues out there as well, the education component of the industry and our customers and our colleagues across the board is ongoing, and it's persistent, and it's in depth, and it's never ending. So what you'll see is our basically our ability to go through and handle some of the needs for the industry, but also the requirement to educate on what those needs are. Just to let you know some interesting trivia, we have provided communities with their first enhanced 911. Then we helped many of them with their cellular introduction, working with wireless, and now we're moving into the next gen world. So over a quarter century, that's a lot of change for these places. But the bottom line for these changes is always standards. The National Emergency Number Association, NENA, you'll hear me saying that quite often today. It's an ANSI accredited organization. ANSI provides national standardization criteria by which standards are created through consensus effort in groups. These standards have been undergoing continual evolution for more than a decade with regards to next generation in particular. The standards that are both already out there and ones that are underway are typically cited in state, regional, county, and city requests for proposals, RFPs. And I'm going to ask Jim to talk about this for a sec. We see these standards, even ones that are in draft form, cited continually. And the ones we'll go over today are the ones that are focused on GIS data, GIS specific. We'll get into the details in a minute. And here's the trick. While we're required to support these and respond that we can support these, all of our company and other companies, the standards themselves are not always understood. Jim, can you give us some examples of what we see?
Love to tie this and the slide before back together. Where we see constant change, and we should all expect constant change around 911. The need for constant education is driven by two factors. The first being that the standards that we're talking about themselves are not static. There is a self-fulfilling prophecy that came along when NENA decided to call it Next Generation 911, not just simply a packet switch 911 or a version 2 911, but next. And when you read that, know that after, even though, like Richard had pointed out, these standards have been in development for more than 10 years. They are nowhere near the actual end state we're going to be. And so for the folks on this call, for the audience here, something to keep in mind that we see over and over again is that a request for proposal, a project coming down to a scope of work will often have an over-reliance on standard, saying just requiring standards compliance does not mean that you're going to get to the end goal, and that it is extremely important in very simple language to describe what is the goal. What are we trying to provide for our constituents? Because just saying that we're going to do things in a standard compliant way gets us only part of the way towards what we need to do. And
Go ahead, Jim.
And just to finish there, getting part of the way, being standard compliant, these standards coming out of NENA are all based on assumptions that the communication system doesn't always meet yet. So we see a lot of strain and a lot of problem in projects that are coming from the idea that 911 is making the decision to move to next generation 911.
Yeah. And
911 is preparing for next generation 911 and has no control over the public switch telephone network. And just simply stating that we're going to be I3 compliant or we're going to comply with these list of standards does not actually provide value, and actually hinders providing value during the transitional stage. Because we all know that in the end, we're all going to want to have an interoperable standard-based system for the United States.
So Jim, I put this slide up of the standards. I believe you've been involved in a lot of these. I know I certainly have. Just wanted you folks to see, we're not showing you anything that isn't GIS related. And every one of these standards or guidance documents, and some are standards, some are informational documents, some are requirements, have an impact on the data required by local governments within each of the states. And that really comes down to who has the awareness of what's necessary. And sometimes it takes a larger project, whether it's a consortium of counties, whether it's a state level effort, but quite often there's a lack of awareness of what each of these are, or even that they exist, that has an impact on what the expectation is their data should be in a particular format or utilized a certain way. Note that we've got these coded. Green are the ones that are complete in existence, and ones that are in red are revisions of those standards that are currently underway right now. So if you'll note that the i3 architecture at the top, STA010, version 4, that's the architecture for the whole kit and caboodle, the whole shebang. And that Jim is involved. He leads our organization's representation on that. And then you go through the rest of them. CLDXF, the Civic Location Data Exchange format, very much a derivative of the FGDC standards on how you define a specific location. These are all very important aspects that originate typically at the federal or state level as far as what's expected for location information in a GIS format, and usually evolves into a NENA standard of some such. For example, the GIS data model, which is this several bullets down, about midway down, that data model stipulates what the schemas are. We'll talk about that in a minute, and right under it, the stewardship, how to build data. So there's a lot going on here. And for those of you who haven't seen these diagrams, I need you to understand that Next-Gen 9-1 can be complicated. And this is not a crash course in it, but what I want to ask you to look at is look at the ESINet, the little cloud in the middle. It's basically a private internet for 911. It's the Emergency Services IP network. And it really is what it sounds like. It's that cloud, a secure network protected by servers and firewalls, that kind of thing. And it utilizes GIS data in that little box in the middle top of the cloud called the Emergency Call Routing Function, the ECRF. Data comes to it from a variety of different ways, but it determines where a call goes based on GIS data. So if you ever looked up something in Google or a navigation device on your phone, same deal. We get a location input from that little box at the bottom, which is called the Emergency Services Routing Proxy, the ESRP. It's kind of like the operator. It's trying to say, hello, ECRF box, tell me where this call needs to go, which 911 center, based on where the caller's from. And that ECRF is stocked with GIS data. Now, before we do that, guess what? Standards on how every one of these things are built, provisioned, operate, and those are the standards in green for each of those as they stand today. However, as of today, from this moment on, they're changing. So if we've used these today, and these are the ones that are available right now in a complete form, here's the new version that's underway. Notice anything interesting about this? Everything in red is that version in a new version that's in play right now that's being worked on. I have a special note on the bottom right where you see that i3 architecture we talked about, very important. That's very important to understand because it's 700 plus pages of how all this is going to work, including the role of GIS data in it. And the 3D GIS requirements is going to take it to a whole new level from two-dimensional data representation and utilization to three-dimensional, where we worry about the vertical factor in how we route calls or how we visualize it, how we deal with responders. So 3D is important. I know I'm on that work group, and we'll try to provide more on the 3D aspect as the year 2022 rolls up on us. Okay, quite a bit of change from where they are right now. If you want to go look up on the internet at the NENA site to where they're going to be within the next few years, we'll have new versions of all of these. So a lot of work's always underway. But our big challenge is we're communicating this to you. How do we communicate this through projects? Now, the projects we worked on, our lesson in the field is it never stops. And it starts with two terms. One is geodetic, okay? And geodetic, when we talk about geodetic location, geodetic gets used for all kinds of things, particularly in GIS and geography speak. But for us, when we talk about a geodetic location, we're talking about an X and Y for now. It'll also mean Z, but we're going to keep that out so we don't confuse things. So right now we have to understand that an XY, a latitude, longitude coordinates for a caller or location is utilized as the primary form to handle most of the wireless calls. And that's important. We use a variety of data sets to figure out where that XY, where it's coming from and where it needs to go. And in a simple example, I get an XY, that ECRF, that call routing box we talked about, if I have a GIS layer for the boundaries, the extent of the jurisdiction from 911 centers, it does a GIS. It really does it. It does a point polygon compare. This is what I tried to explain to my mom all these years. What I do, I build data so a box that's not manned by anybody can automatically figure out where to go all by itself. It's an amazing thing, and it's done in milliseconds. to figure out where that location is. The civic location is a different animal. We had geodetic, which was the XY. The civic is going to be your, what we used to call landline or typical regular location address 105 Main Street, something like that, okay? We have two functions. We have an LVF function and an ECRF. We won't get into the location validation other than to say every type of data that goes into this 911 system for verifying where something is has to be checked against GIS data. So GIS data checks the quality of location information and helps in routing. So the ECRF, it's real important to understand that we provision that primarily with road center lines, which you'll hear me talk about and you'll see on the screen as RCLs and APs, address points. Jim, did you have any points on this, the civic validation and routing you wanted to make? It's just a FY for them before we go to the next slide.
Absolutely, absolutely. With civic routing and validation, it's often important to think back and remind yourself that, well, the problem that next generation 911 is trying to solve is the same problem that E911 has solved with ALI and MSAG. And that it's important sometimes to take a step back and look at ECRF and LVF and understand that this is an effort the industry is going through to solve the same problems, the same issues, provide the same level of data, just with new tooling.
The thing about LVF, go back to the example here. XY, I just need to figure out where that call falls in. You'll see on the little outline of those two polygons, PSAP A and PSAP B. Where does it fall? And that polygon has routing information. Think of it as a web address of where the 911 center is going to get the call. However, when we're doing validation and routing without an XY, which is what we're talking about, I've got a 105 Main Street, I can't compare it to an XY. I have to figure out where it is on some kind of geometry, which can then be interpreted as an XY. We call that geocoding in our business, right? When we take a road center line, geocode a location or something like that, or even address points to figure out which one there is. One of the things you're going to see on the next bit is we have a lot of discussion about, is 105 Main enough, or do I need to have additional information like building 3, for third floor, suite 2? That's called subaddressing. While that's not a critical issue, and we'll get more into subaddressing later, it's something we have to keep in mind because in the future, that's going to be an important aspect for narrowing down or refining someone's location. So we'll go to the next example. This is what we would look at for, again, a civic. I've got it in red here as opposed to geodetic. When I don't have an X and Y and I have a location like 105 Walnut, I'll use a street. I'll use a street center line to geocode that, and then I do an offset, right or left, wherever it goes. However, there may be instances where the specificity of a building is important. Like you see on the example here, building 1 and building 2 are split by a jurisdiction. Down here in Austin, Texas, that area where I'm at, we have the Dell computer complex, and that spans quite a large area. It's quite likely that some of the jurisdiction lines can go between buildings, depending on which county responds to it. So if that's the case, knowing which building you're in is important, and you can't really determine that without subaddressing, like building 2 in this example. So
Right.
notice on the left, the required layers for this type of location is not just PSAP boundaries as it was for geodetic, the XY. It's now the road center lines and site structure. Now here's where it comes into play. We have to build this data for 911. We as an industry in 911, myself, my colleagues as well, and the other companies out there have to work with the counties throughout the country, right? All 3,000 plus of the centers out there and Canada. Now, it's important to understand that there's a lot of variation. The states do what they can based on the standards they have at the time and have been for years. The states can come in and provide a lot of continuity and consistency of what's built and how. This takes us to the question of schemas, database schemas, local versus national. As I mentioned earlier, there's the 911 GIS data model that NINA has put out there. The definition of next generation core services are those elements, those things you saw in that little cloud diagram that take in a location, figure out where it needs to, the call needs to be sent to, and then pushes that call to the correct location, right? This is an example. I took this from the data model of just the schema for the address points. Notice you've got the descriptive name, a field name. Field name's a 10-digit, a 10-character field like we're used to when you have to have some short fields. But we also have the MCO column. That's mandatory, conditional, and optional. We have a type, whether it's date or whatever, and then a field width. This is really the Bible for what we're going to use for these things. Within it, note that there are several key attributes that we need to use for this routing capability. And it goes, as you would imagine, with geography, largest to smallest. Country, state, county, additional code, and that's going to be a Canadian designation. And then we have other information such as municipality and community. Notice the ones that are O for optional and the M for mandatory that we have to get from local governments or someone has to provide. There's also the legacy information. You may have US 183 as a road, but it may also be called First Street when it's downtown in a small community. If that's the case, or Main Street, that legacy name may be something we need to keep track of and convert. Because if it comes in as Main and the GIS data says it's US 183, we need to have these systems be able to convert. Think of them as aliasing. But that data is captured in the address point layer in this example. Same for road center lines. And then we have subaddressing. Now, the challenge with subaddressing is while we'd like to have it and want to use it, and it will be important in the future, the existing telephone company databases, the structures we have today across the board, do not currently support the input of a building, floor, unit, room, seat consistently throughout the United States, nor will they likely be. Jim, can you mention some of the things we've run into with data development and the needs for people, how they're understanding what they have to provide for, in this case, address points or road center lines?
Absolutely, absolutely. So I'd like to to help amplify some of this and tie back to the slide where you were showing the civic address location, because this is an important, very important concept for folks defining what has to be done in your location. Yeah, perfect. What has to be done in your jurisdictions? What has to be done for a project to get the results that the public and the agency the agency with the authority for the public trust is going to accomplish? And that is not usefully defined by a cookie cutter approach. Because here we see in this example, we see that we do have the complexity involved where we have the same address with two different responders. So this is what dictates that we need to have sub-addressing support. The standard allowing sub-addressing and dictating a pathway for sub-addressing does not dictate what is required to improve emergency response in your location. The data,
Absolutely.
the environment that you work in does.
And Jim, I would add, I've got a note there which says APs, again, address points, site structure address points, support dispatchable locations. Jim and I have been struggling for a long time to make it clear that dispatchable locations doesn't mean it's necessarily 911 dispatchable, i.e. from the dispatch center, the communication center, or the PSAP. What that term refers to, we talked about this in some of the other presentations we've gone through, is that when referring to the Federal Communications Commission understanding of that additional or sub-addressing, it's referred to as dispatchable locations. It provides enough uniqueness in its granularity to distinguish a location, floor, unit, room, height, all that, different from anything else. And this goes back to what I was mentioning with FGDC, all right? The FGC has a very granular way to determine locations, and that's been passed on through NENA standards and is represented to a large degree in the data model. That's why we have that sub-addressing. So just bear in mind that sub-addressing is something. And Jim, would you say we see a lot of sites right now that are having sub-addressing working on it? What do we typically work with sites, and what's the vibe on what they're trying to build and keep current?
Well, what we've noticed is that there's a lot of good work being done on spatial data to support emergency response. But we also see and feel directly the opportunity cost when data is being fixed that doesn't need to be fixed to meet their goals. We have come across a number of localities that are working on providing sub-addressing down to the apartment and condo level. So they're taking their address point data and they are increasing it, sometimes doubling the size of the address points that are contained in their data to reflect 20-story condo buildings along the ocean. But the work that they're putting in, while good work to be more specific and more granular,
Yeah.
has zero effect on emergency response. And since they're not working in a three-dimensional environment, the majority of them wind up with just a shotgun pattern of dots laid on
Yeah.
top of an aerial, one for each apartment or one for each condo that's recognized in a parcel data layer. And
I'm going to
so
bring
we
something up, Jim.
see, we see the people coming together and putting work in that it will be valuable work in the future, but unfortunately it's not paying any dividends today. And that directly relates to this next slide here.
What we're going to do, Mike, we'll see these questions when they come up. We'll try to answer them at the end, but I'm going to go ahead and throw this one out there. We see a lot of gaps in the customers, and we'll talk about some of that at the end here when we do the prep review. But I would say, in answer to your question and what we're talking about here, notice that, as we all learn as geographers and GIS people, largest to smallest geography is a good way to look at your data. And in this instance, what we're talking about here is that these fields for country, state, county, and corporate, all these different fields are important to be provisioned from top to bottom. Here's an example in New York, how we would have that checked. If we're doing the identification of whether something's valid or not in the LVF, in other words, is there only one unique physical feature with the attributes that can be used for the routing, as we saw for Civic? This is important to make sure we can find that, and we will have checked and unchecked. We won't spend a lot of time on this, but bear in mind that the fields for the location of the state it's in, the county, the municipality, all these are important. Street name, by the time you get to street name, you're going to have a unique location for that call to go to before you even get to the myriad of individual components pre-modifier, because you could have Main Street, North Main Street, South Main Street, North Main Street, South Boulevard, business. There's all kinds of variations. Again, we go back to the CLDXF. The data model NINA uses for this type functionality is, again, a derivative through the CLDXF, the Civic Location Data Exchange Format standard they built off of the FGDC's recommendations on how to find location. And you'll know way down here, after we get past all the name components and the address number, by that point, if you have to go beyond that, you're probably not going to need all these things with building, floor, and unit. So I would say out of, Jim, what 90% of our calls are going to get what they need from the XY, and maybe 10% or less are going to finally utilize the roads for Civic location. And even then, I would say almost all of them don't even get past the community for routing.
Exactly. And that is really a question for your organizations to decide what data is required to meet my goals. Not
Absolutely.
what data is required just because there's a place to put data, but what data is required to meet my goals. Because as Richard pointed out, wireless calls that come in geodetic, those are going to be routed. Those are a majority in places. 80-90% of the calls are coming in wireless. And the places that are that do the number of calls that come in Civic, those Civics are usually routed well before we get down to actually the specific address.
So this is the point where if I was on a stage, I'd turn my chair around, sit backwards in it and say, can we talk? Here's the thing I've been providing. I function as NINA's liaison to NSGIC. And I'm very, very happy to have done that for a while now. And one of the things we try to pass on from the NINA organization itself is that the PSAP boundaries themselves, the Public Safety Answering Point or Emergency Communication Center boundaries, are really predicated on jurisdictional lines as far as the extent. We're talking about the county line and the state lines. Those are so critical that we have something that's utilized for 911 that we could basically poses as the puzzle frame that we could align PSAP boundaries to, not because each county can't come up with its own, it certainly can. It's the problem where we have counties that have gaps and overlaps between their polygon boundaries. And the jurisdictions for these communication centers are important. For that, we need good, stable, or at least universally recognized county and state lines within each state, whether you're Arkansas or Washington or Florida, that is a predicate for everybody getting on the same page and working between jurisdictions. Jim, I would say that's our biggest challenge, is having those county and state outlines that are consistent, that everybody agrees to use to build their data within, if I'm not mistaken.
Absolutely. And probably a majority of our audience here knows all too well that there is no such thing as a perfect legal boundary most of the time. We have different uses, different organizations, and different understandings of boundaries.
Yeah.
And one of the important things for 911 moving forward, to be able to get to the ability of utilizing a next-gen system without getting stuck on data, is to understand what data is actually under their control, and to make agreements and alliances about where PSAP boundaries are going to lie without having to first feel like they must solve the legal issue of where a legal boundary lies.
Yes. And the service boundaries, the responders, fire, law, and medical, that's a different world too. We used to just have a number, an emergency service number, a unique ID number for every single location and address that determined what your fire, law, and medical responders were and where it went. It was tied to this unique 3-digit number for your jurisdiction. Now we have to have separate layers for fire, law, and medical, and anything else you want. It's great that it provides all kinds of layers that you can use in addition to the 3 basics. And it's terrible because it can provide all kinds of layers in addition to the 3 basics you need. So it's a two-edged sword. But we find, Jim, I think most people are working very hard through the standards. We talk about gaps and overlaps. Computer-aided dispatch, these CAD systems that we use today haven't been really part of the flow and the necessity. However, that's going to change. I know with an APCO, where I serve on the standards development advisor group, we talk about how CAD, at some point, CAD systems from different companies, there's many of them, will at some point find it advantageous to consume the data that's distributed through this ESINet. We haven't talked about distribution, but the goal is when you build data, road center lines, polygon boundaries, address points, and distribute that to all the systems in 911 that need it, you'll be able to also distribute it to CAD systems and to larger hubs or wherever it needs to go. That's the beauty of this network of networks, the emergency services IP network that's being built. There's a lot of promise in what that can do for the United States, for consistency of data, for timeliness of data. It's been a challenge across the board, and it will be something the CAD companies can take advantage of as well. But bear in mind that this takes a lot of work of technology, how to put it in place. Things are changing, not only standards change, but the annexations take place. When an annexation takes place, we need to get that data updated. It is going to be based on the need of local governments to update those polygon boundaries, because if you do annexations and your ambulance routes change and your fire response areas change and you're expanding or shrinking them, you need to reflect those changes right away in the GIS data. So we need to have a quick way to identify those changes and update them, even have systems respond to those based on a time basis. Jim, you've had situations where people have needed to, let's be careful about this, how we've had to update a polygon boundary. Can you anonymously give an anecdote about a polygon boundary needed to be updated with a surprising repercussion?
Oh, yeah, absolutely. We're back to the issue of there not being a perfect legal boundary. There not being a perfect answer. And so we see many instances where a lot of effort, a lot of confusion starts being generated by how to define boundaries and where to define boundaries. And we have the real world is much more complicated and has many more factors than we ever have represented in the GIS simplification of the real world. And so we see lots of, we get field questions all the time between organizations that are trying to work their boundaries, and they're trying to decide, they're actively arguing, well, should the line actually be where the pavement changes between my county and their county? Should it be where the sign is sitting on the highway?
You see this example here of where things could be broken.
Yeah. And so we see lots of instances where the decision on where to break that boundary becomes is we have to make sure that with the software in place and the processes in place, that we are keeping people aware of the actual outcome of their decisions. And that's not always completely understood at the local level, because we start getting into discussions, and we've seen this happen on the national stage in standards development, where people are having discussions about when and how to break road center lines and for what attributes they need to be broken. And we have seen, I'm stumbling here because I don't want to be too pointed, but we have seen people who have leadership quality in the industry say, well, you don't have to break it if it's just crossing a city boundary. And they are making decisions, and people are having discussions that are really eating at the very nature of the foundation of how road center lines and spatial data in general are put together.
Yeah.
And we have unfortunately seen that process go all the way to being put into the guiding document and established as a procedure to say that, well, you don't always have to have the right data on the road center line.
Yeah, I'm going to go back for a sec, Jim. When we talk about annexations, when we talked about where things get added, we've even seen instances where a polygon needed to have routing change for it. Maybe there was a change between a government-based organization's boundary and something that was on the civilian side in the county that's not necessarily part of the federal government. In that instance, we've seen instances where a GIS person may need to make a change. Maybe it's a Friday at 5 o'clock. They want to make sure they get that new polygon in there before they go home for the weekend. They do. Suddenly, when they did, calls are now getting routed to this brand new polygon, as they should, but unfortunately all calls get routed. And then you have situations where the service providers, the companies that are facilitating the whole project, like going, what's this GSI stuff? What's this routing? All the calls are routing the wrong place. What's going on? It's 2 a.m. on a Saturday. Where's your GIS person? I mean, that we're getting to a point where the expertise needed to be able to build this data, not only build it and upload it, but correct it if there's a problem. You literally have people looking around, says, where are the override? Where's the override? Who have no knowledge whatsoever of GIS data or the systems that are driven by it. So we have to we can't just say, where's the undo button? How do I roll back to the last data set? We have to have expertise doing the work necessary, but on call potentially as well. So we ourselves see, just look at the definitions for site, structure, and address that Nina has to codify and make sure everybody's consistent on. We're getting to the point where having people knowledgeable about GIS is important for the companies delivering services and products. It's important for the local governments doing the work or basically contracting for the work. And it's important for the state and federal agencies to understand what needs to be built, how it needs to be built, how it's going to be used, and how it's being updated, because they may need to have that. It may work its way into their data, and hopefully not. Maybe it's contradictory. Maybe it's at odds against some of the data that's used for other state and federal agencies. So understanding what's happening and understanding that, for example, the site structure address points, you haven't figured out already, it's a great in-state goal and it's needed for dispatchable locations, but may not be the necessity, is really important. So much so that even in the data itself, another snippet from the data model, we have, and this is a section from the road center lines, we've actually got fields in the data model. This is the National Emergency Number Association GIS data model. Version 2 is wrapping up now, where you have an option to say, make your road center line validate left and right, yes or no, with address points. So you can actually have your road center line say, use it for making sure calls can be routed or used through this, or you could say, no, if I don't have it, flag it as a problem and make me put an address point there. So we're now where we can get data to tell us when we have a problem as we're building it for test queries. And we can use existing ALI or other 911 database testing environments for this. And it's important to understand the GIS data, the more fields we add, the more information, that's more we have to maintain. Look at the left and right validation. If we want to make our road center lines every segment, say whether or not to use it or the address points, which are what these two fields do. Taking Houston, they have 350,000 road segments, doubled for left and right. That's 700,000 attributes. Do you want to manage 700,000 attributes for the 2 to 3 million points they have in real time and be responsible for that? This is what we're talking about, the gravity, the enormity of the data we'll have to keep up with. And the problems that we encounter, there's fixes to them. Some of them are ugly. We'll have an example where address points may not be available. Maybe they're inconsistent with the roads. And in this example here, you may have an address point, 1947, where it would geocode way off the way. Mrs. Humbug doesn't want to change. She wants to keep her address. It's always been 1947 since 1947. So even though her address is somewhere else way up the road, she's going to keep it. So we've seen sites that'll use a road center line. Remember, for the 10% of calls that have to geocode to figure out where that XY wouldn't be, this may be a workaround. So we see sites doing that. Jim, I think you've seen sites doing this. And this goes back to your phrase of building intelligence, building programming into the GIS data for routing, right?
Mm-hmm. Yeah, because the decision of how to route calls is never given up to a machine. The decision always rests with the person who's drawing the data.
Think about that. So all of you building data, all of you aware of who's building data, you're not just building GIS data to use for mapping or routing, you're building decisions. You're making the decisions on how data routes in 911. And when that data is built, here's another example of address points. We have address points quite often, so emergency response in the CAD system or 911 response system, they'll know where that mailbox is. They'll know where the driveway is. That doesn't necessarily mean that's where the call needs to be routed to. We have to think of how calls are routed and how calls are handled in the 911 centers. And you can have it both ways. You can have a data set that's used for call routing, in this case, where a point is actually where the caller location is as far as a landline or civic structure. And you can still have them for your map display, your CAD system, for where you're trying to determine where the units need to be routed to and where the call needs to be assigned to by a driveway or a mailbox. These things have to be considered. In this example, A and B, you'll see the 105 and 106 fall in PSAP A. And the address 104 falls within PSAP B. They're color coded. But originally they were the little green dots, which may be arbitrary. It may not, they may fall in the wrong address if they're all on that line. And that's just a specific geoprocessing. Mm-hmm. And even things, Jim, I think you've run into this multi-points where you may have a need where, and we've talked about that. Gosh, the things we talk about in these work groups, and all of you are welcome to participate if you're not already in a work group. If you have some GIS knowledge and work with addressing, you're welcome to bring it to bear. You can contact me and Jim through our friends here at NSGIC afterwards. But note that with a multi-points where you have multiple geometry elements associated with a single database record, a lot of times, I know I do, would snort at it and go, I wouldn't do that. Well, if you don't have subaddressing, there's no way to put it in there, but you have individual floor plans, blueprints, or maybe you just have pictures of the fronts of the buildings to understand access points. You may need to do hyperlinks and attach those to a specific address. We've had sites that wanted to have roof lines, the top of the roofs attached to individual points, but there may be multiple points. We'll go back to a complex or a university. They all have the same address. So what do you do if you want to do point and click, and again, go back to your CAD or your Map Galley or whatever, your emergency notification system? Multi-points have a value, but this is something Nina's got to figure out. What kind of guidance, if any, do we provide on it? Because you'll have advocates on these groups that say multi-points bad, don't do, or multi-points can't live without them. And Jim, you've seen that.
And it comes back, if I can jump in here, Richard, it comes back to the requirements in use today. I'd like to reach back to this idea that there is no one standard that can be applied in all situations. As Richard said, there may be a CAD or a map or some other system in use that requires one type of data or the other. And a large regional system made up of many different addressing authorities and many different data providers often cannot have the simplicity to say, thou shalt always do it one way.
Right. And look at
that's what we see often. Yeah,
as Jim's been saying, do we even need subaddressing? Some will say we don't need it right now. Others will say we have to have it. And we won't get into the pros and cons. That's a whole session by itself on subaddressing how. But then we start talking about, okay, if I put the building in the unit room floor, what's my maintenance? What does my maintenance future look like? How often do configurable buildings strip malls change? All the suites. How often do suites in the floor change over time? Who's going to keep up with that? Is there a system in place at the county that keeps track of all the changes of all the locations? Probably not. And it's a nightmare. I go back to, someplace like Houston or New York or LA, where they have millions of points. Now multiply that. That's just with no subaddressing. You add subaddressing, let's say you have 2 million for Houston today, that could easily quadruple that. Imagine if you had 4 million address points you have to manage, and each one has about 50 attributes you're keeping up. The math boggles the mind. And how much staff do you have? 3, 4, 5? It's tough. And then we're going to add 3D to it later. We want to be able to see and manage things at elevation. What does that mean? Oh, and by the way, I have to worry about funding and turnover and policies. So all this being said, what we see in the field, and this is what we've tried to talk about with our clients, we try to talk about this with our partners. We talk about this at NENA and APCO and NSGIC and URISA and everywhere else. What are the bottom line things we need to get today? Look at this step pyramid. We're looking at MSAG and a PSAP boundary. This is available today. If we get that focused, then we can work on building good road center line and responder boundaries, which most places have. They've already used in road center lines and responder boundaries, fire alarm, medical, a lot of them for CAD systems. A lot of that just needs to be compared to the schema to make sure it's good. You'll note that we have on the right where we're stipulating the PSAP's used for routing, the MSAG's used for responders, that first level. But when we graduate up to the next level, then we're talking about law, fire, EMS are necessary to replace the MSAG role as responders, along with the RCLs, and then the PSAPs for routing. Then we go to true I3. We're going from NGCS preparation, then we go to true I3 routing. We have law, fire, EMS responders, APs, RCLs, and PSAPs. This is what our goal is, and it should be. But in the interim, we can't depend on every data set being the best it can be. It will need time. So if you think of this as a series of steps or landings, and for me, using these different flights of stairs is helpful. If we know that I get a location query coming in, that's a little parachute with a box there, and it's coming into the LVF ECRF, and I'm going to search for that location. We're talking about a civic location, not geodetic. Geodetic straightforward. The X and Y, we can deal with that. This is a 105 Main Street. I'm going to look it up, hopefully using address points. If not, well, I got road center lines. If I don't have that, and I'm still dealing with, I don't have an ESINet yet, I'm just now building that, maybe I want to start off with MSAGs. Our goal, no matter what, is to stop that last landing, the default routing from happening. What do I do if all else fails? I'm going to default route it. We want to stop that. We want to get a better, faster, more accurate route to the correct center. We can't afford a difference between 5 and 45 minute of dispatch because we got the sheriff's office instead of the PD. That's real important. So not only is this important to understand how you prep your data and how you use it from the bottom up, but also that there are systems that can utilize multiple layers of data. So instead of going from bottom up and building the data as fast as you can, get to the top of the stairs, you can start at the top of the stairs by adding address points, row center lines, and MSAG as you have them today and have it search that way. And that's what we recommend a lot of sites. That's what we talk about at NENA. That's what we talk about, I think our colleagues, we talk about that as well. And many places are starting off with the Master Tree Address Guide, the MSAG, the traditional 911 database for now. And when we go to this, I know we're running down on time, we've got about 5 minutes left. When we talk about, and again, NG9-1, it stands for Next Generation 911. Where do we start? How do we check through this data and go through it? Looking at their biggest bang for the buck, we recommend and have worked with people all throughout the country that we start with work on the geometry. Do we have the geometry present necessary for the points, lines, and polygons? And NENA has a stewardship guidance document for this. And when we work with states, many of the states are aware of the data model, the NENA data model, but not necessarily this new GIS data stewardship document, version 2, that's not quite out yet. Version 1 is, it only covers PSAPs, but version 2 is going to cover the road center lines, and it's going to cover the responders. It will be a fundamental shift on how we build and process data, which will have the steps recommended for building and maintaining it. The GIS schemas and the data model, critical. Talks about the key layers within it, and then attribution. I've underlined those 3 to keep in mind. If you're thinking of the big 3 items, geometry, schemas, and attribution, you need the geometry, you need the geometry present, you need the schemas. That all of the GIS data schemas need to be consistent with a national model for interoperability, for data exchange, for consistency in work, and the attribution needs to be present and correct. Those are the 3 big takeaways we recommend. And starting with polygons, working your way down from polygons to streets to points, usually advisable. You don't want to fix 1,000 address points, then realize, oh, I was fixing them to my roads, my road names were off. oh, you know what, my road attributes for community were wrong because my polygons were off. We recommend flipping that, do the polygons, roads, and then points when you're building that civic location necessary data. And then we always recommend comparing that legacy 9-1 data to the GIS RCLs. So all this is important in what we're talking about for building and managing the data. But for us, Jim, I think you'd agree, the maintenance is the important key aspect. Here's where the states can really help out and play even more of a role. Everybody needs to have a plan at local government level, and preferably it's something that their neighbors are following as well. We have to deal with turnover. That seems to be I know my colleagues in the industry will tell you, turnover at local governments we're working with or for is terrible. It keeps happening. We can't keep, now as soon as someone understands what GSI is and they know how to turn on the software and draw a line, they're hired somewhere else. It's an invaluable skill set to have that GIS capability. And for states, I can see the states continue to provide that institutional continuity when we have programs crater at counties. And it will happen. It's just part of the business. But consistency and continuity, if you document this stuff at the local level, and even if the state has a plan, and most states do have a great repository or capability, making sure the links to 911 are there could be very, very helpful. Jim, would you agree?
Absolutely. Absolutely. The continuity, and not just continuity of skill or capability, but the continuity of vision, so that everyone in the project, everyone in the chain of authority that's doing this work for the public understands what the goal is and why they do what they do.
This slide,
extremely important.
Yeah, this slide may be one of the most important we talk about today, because I don't want to sound like I'm pleading. I kind of am, but understanding everybody on the call that the two of the biggest challenges of our time is having consistent boundaries for counties and states. That is just an imperative for success across the United States for building good, consistent, seamless GIS data. And the second thing behind that is having that knowledge that's retained and leveraged by local governments, maybe in concert with states. We've got to keep this data rolling, because our turnaround time, if we have a problem and we're missing a polygon or a road's missing or it's wrong and we have a misroute, it has to get fixed and basically updated as soon as possible. I think the typical working time is 3 business days to get a response on it. Think about that. You got a one-person shop and they're taking a week off from vacation. What happens if your routing system using your road center lines doesn't route properly because you're missing a whole subdivision? Who's going to put that in? And who's liable if it doesn't get put in and it misroutes again and there's a bad outcome? This is important. Not only that, but you have to be able to go in and check your data at least annually. Now we're seeing in these situations, local government saying, hey, I want to go ahead and have redundancy. I want 2, I want 3 of these GIS servers. Think about the knowledge you have to set up a hub or a GIS server. Also, what happens if it fails? Who's going to bring it back online? And then how often do I need to test that and reevaluate my data? I'm not sure how this is done or handled a lot of the state organizations, but I know local governments are going to start asking these questions you guys at the states have been looking at for a long time. How good is my data now? What happens if I lose it? How fast can I recover? What happens if I find an error? What's my process for remediation? How do I document that? How do I let people know I've remediated? How do I track those changes? And again, I put a note in on what we've got growing for the need for halo data. Jim, you run into this. This is a new term we see more and more. People asking for halo data that's a periphery on the buffer. We're almost done here. We got a couple more slides. But knowing what the neighbors are, there's hesitancy if neighbors provide data. We have states where we work on a project and the next door state will call us out of the blue saying, what are you doing? Counties along our border are asking for our data from the state. Why? And we're having to explain this all over again, why neighbors along borders of states or counties need their neighbor data, because they have to be able to handle calls that are along the line, because there's variability in that location along the county line. So that's going to be a challenge. And adjacency is important for gaps and overlaps. Last slide I'd leave you with, because we're out of time here, was industry trends in the future. I would say for us, a lot of things we talked about, I see national data hubs as an imperative of the future. We talked about the National Address Database, the NAD for a long time. I can see that being instrumental and a huge component going forward of that institutional continuity, where counties may lose a lot of staff, they may not have access to regularly updated data, or they don't have good data to start with. That hub could be phenomenal. Plus provide consistency across jurisdictions. Sustainable data renewal channels for national hubs. It's not enough to have those hubs. They have to be renewed like a ever replenishing spring, a wellspring of new data. That's going to depend upon local data relationships, as we all know with the states. I can see for public safety from now on, that being a huge impetus for getting those programs to expand beyond the NAD to things like a road center line database. There's already a national polygon database for PSAPs, but that's not public accessible. I can see a lot more going that way. Automation of data reporting that goes along with these two, maintenance and provisioning. Live streaming support. Not only does data go in, but being able to have the data out. We see more and more on RFPs where local governments don't just want weather streamed in as WMS or WTS. They want the ability to attack and attach outside external data sources. That's the reality. We talk to different companies. That's what they're willing to offer. We're seeing, I just got an ad the other day for live streaming weather here at the house on any device I want. Same for public safety, being able to have this data coming in. We see that on the horizon. And of course, the big one, we're going to see a lot of this in 2022 is 3D, height elevation. That's a big one for us out there. Okay, that was fast. We ran out of time. Amy, thank you for letting me run a couple more minutes. We have 3 minutes for questions, I think.
Yeah, of course. And just to let everyone know, if your question does not get answered, you can send it to info@nsgic.org. Put that in the chat right now. I will be happy to send that along to Richard and Jim. So our first question is from, let's see.
We got the CAD one. We got a first couple done.
Oh, okay. So the question from Mike Bergen, what is the biggest gaps the customers see with these layers?
Yeah, I think we talked about that. You know, again,
Okay.
having that consistency for a framework is important because it's kind of a moot point till we get that. But yeah, we have gaps between jurisdictions is big. And usually the gaps between address points, road center lines, just talking about data completeness. Road center lines are usually easy peasy. They're there, they're available, not super accurate, but for the limited amount of use they're going to be needed for, they serve right now until the address points can get up to speed.
And then a question from Kim Wall. In rural areas with long driveways, do you recommend mapping private driveways to the site/structure address points and access points where the driveway intersects the nearest address RCL?
Yeah, so the address points need to be two purposes. One, for the emergency call routing function, where it's automatically routing a call based on its location of the caller. Those points need to be where the location of the structure is. But for CAD, computer dispatch, mapped out and other things, you're going to want a set of points that are where the mailbox is, the driveway, so that your CAD system can adapt to where to get the units to. That both are important. So we may get to the point now where we need both. We need something for routing and we need something for the location. But there's, as with everything else we talked about, there's an art to this. You might be able to get away with both depending on where you place the point, but that's a case-by-case decision.
Okay, and I have time for one more question from Pete Croswell. Is the address data standard being adopted for jurisdictional entities in Canada, provinces, not states? In your opinion, do the county and municipality data fields cover all types of jurisdictional geographies in the US and Canada? City, county governments, towns, and townships in certain states?
Yeah, so on the Canadian part, the GIS data model version 2, which is being wrapped up now, again, I'm welcome any queries. I can tell you about that, being on that group. We have a lot of members from Canada, from different provinces around the country that are providing input. It's also, Jim, I think it's a major concern within the I3 group because the Canadian needs as well. We have great Canadian representation in our key GIS work groups and GIS aspects that we take that into account. So when you see ad code and other things, we've adapted that in there. And the version 2 will cite Canada specific on some of the things that are necessary for Canada specifically, and some that are just universal.
Yeah, and the only thing I would add there is the Canadian specific petaflow profile, the Canadian CLDXF is also on the way.
Jim works a lot in the Canadian area. He's working in the Western Canada area, so we see a lot of what's going on up there. Again, we're glad to talk with any of our Canadian brethren about some of this stuff, but it's exciting to work on with what's going on in Canada, United States, the islands in the Caribbean, which I never get to go to. It doesn't matter. We're all over the place.
Absolutely, and this fits right. That's a great leading question here, because this fits right back into our discussion of the need for education and to simplify the understanding for every stakeholder in the chain, because we see a lot of push now The 911 system borrows much, if not all, from larger IETF standards that were built to address the problem worldwide.
That's
And
right.
so we have folks right now that are very hotly lobbying that we should not have such a thing as state, county, and an incorporated municipality. We should call them A1, A2, and A3,
Yeah.
because those are the more generic administrative division terms that have been proposed for the entire world. And while that makes more sense in a standard, it makes it less available to someone who's coming on the job working for 911. Oh, what is A2 again?
Yeah. So what I would leave you with, again, Jim and I want to tell you all thank you for the
Yes, thank
time and the ability to present this to you. Please let us know if there's any questions for Amy. We're glad to work with you on this. I will tell you now, if you're interested in GIS work and within the sphere of 911, you will never have want of a job. You may have to go somewhere else, but there are always openings, there's always challenges in maintaining staff across the country in the government sector to do this. It's a perpetual need, and the challenge for education is eternal. I know I'm going to be long gone before we have less need to do education on GIS and GIS principles for public safety. Again, thank you for your time. Amy, thank you for helping us get going this morning.
Yeah, and thank you for everyone attending today's presentation, and a huge thank you to Richard and Jim for this awesome presentation. We apologize for those who did not get their questions, but like I said, you're more than welcome to submit your question to info@nsgic.org, and I'd be happy to pass that along to Richard and Jim. And just a friendly reminder, this will be sent out as a recording, and in that email we'll provide information and on how to reach out for more questions. So once again, thanks Richard and Jim for everything, and thank you to the audience. Y'all enjoy the rest of your Wednesday.
You bet.
Yes,
thank
thank
you
you.
all.